Hello, fellow developers. This video consists of three parts. First part, theoretical points about Spring Boot application deployment on AWS Elastic Container ECS. Second point, theoretical points about the application load balancer ALB. Third point, practical demonstration of deployment on ECS and traffic routing using ALB. Here, this is the architecture diagram. This is the AWS system architecture diagram. First, I will explain the theory points about this. After that, I will explain the application load balancer. Then I will do practicals. Hello everyone. Hope you are doing well. In this video, I will explain about how manually push Docker images to AWS ECR. ECR stands for Elastic Container Registry. It is a registry here. It is a registry AWS ECR. It is a registry. It will store Docker images, right? And deploy a Spring Boot application on AWS ECS. ECS stands for Elastic Container Service. AWS ECS is a orchestrator. It contains task definitions, service, cluster, AWS Forget. AWS Forget is a serverless computing. In AWS Forget, Docker containers are running. Cluster is a logical grouping. Service manages the task definitions. Service contains manages task scaling, load balancing, public IP. By using public IP, we will access the our Spring Boot application. Allow inbound traffic. Inbound traffic 80 is the HTTP default port. This is the 8080 our Spring Boot application port. So this port we are mapped to container port. So suppose here O2 route traffic from AWS ALB to AWS ALB. ALB nothing but application load balancer to AWS ECS forget. Forget is serverless computing, right? O2 route traffic from AWS application load balancer to AWS ECS forget. Elastic Container Service forget. Same process applicable for monolithic and microservices. I will show for single application. Assume like that is a monolithic. If you want to same process for microservice, just you can repeat same steps. Same steps you can repeat another then it is called microservices. Here suppose these are the three containers. Assume these are the three applications are running. So these are the Spring Boot port. Our in locally every Spring application running on 8080 port. But in container where port mapped to this is the welcome map is a 8081. This is the container port. Another application is there. Suppose welcome one. This is welcome one. Welcome one 8082. This is welcome 3. Welcome 1. Welcome to 8083. There are three microservices are running. If you want to three microservices, if you want to deploy an AWS ECS, then you need three task definitions, three services. Cluster either you can use for each microservice, you can create one cluster, or if you are cost efficiency thinking like then you can also deploy in single cluster. AWS Forget is a serverless compute. It will run the containers, right? So in this video, I will cover these 2 points. How manually push Docker images to AWS ECR and deploy a Spring Boot application on AWS ECS. This I will cover. After that, once successfully this is done, up to this I will access through public IP. After this is completed, I will go to route traffic from AWS application load balancer to AWS ECS. Forget. I will show then auto route traffic from application load balancer to AWS ECS. Forget. The same process applicable for monolithic and microservices as well. So let's go to first step. Here this is the first step. In first step, by using Spring Initializer app side, so I am generating welcome app. After that, I am importing into IntelliJ IDEA. So after one successfully imported, I am developing some piece of code, Spring Boot piece of code. I will expose one or two endpoints and I will create a Docker file. After that, I will add some instructions and Docker file. And we are interacting with application load balancer, right? Then for that we are adding target groups. Target groups require one slash health endpoint. So it is mandatory to we need to add one health endpoint is mandatory. We need to add one health endpoint. Remember, yet Spring Boot code, we need to add one health endpoint. Here, scroll down. Note when using an application load balancer and target group, it is mandatory to manually create a slash health endpoint. It is most important. Otherwise, service deployment will be failed. Note when using an application load balancer and target group, it is mandatory to manually create a slash health endpoint in our Spring Boot application as a one REST controller endpoint. So see here, add some one point about this. So first point in that use the Spring initializer website to generate a Spring Boot application. Spring Boot application and then import it into IntelliJ IDE. This is the first point in first step. This is the step 1 in that first point. So yeah, second point. So B in this application, comma, it is mandatory to create a class health endpoint if you are using a application load balancer, nothing but ALB. Otherwise the class health endpoint is not required. required. In this application, it is mandatory to create a health endpoint if you are using a application load balancer. Otherwise, the health endpoint is not required. By using health endpoint only, this application load balancer and target groups will check the health. It is working fine. It is good condition. Our Spring Boot application is good condition. This up. These will check by using health endpoint only. So third third point, the the target group the target group interacts with the slash health endpoint. If you are endpoint endpoint to monitor the application health. It is important point. Applications health. Fourth point, are the remaining code as per the project's requirement. Step 2. I will explain. First, use the Spring Initializer website to generate a Spring Boot application, and then import it into IDE. In the application, it is mandatory to create a /health endpoint if you are using a application load balancer. Otherwise, the /health endpoint is not required. So the target group interacts with the health endpoint to monitor the application health. If you are not configured this /health endpoint, then this target group health will be unhealth. It will show like a unhealth, hence it will not work. It will not work. ECS service, it will not interact without a healthly. This application load balancer without healthly. Without healthly. AWS ECR Elastic Container Service will not interact with load balancer. To get healthly, then we need to add this /health endpoint. This /health endpoint must be we need to create one REST controller, and we need to add at target group. While creating the target group, we need to mention /health endpoint. Here, use the Spring Initializer website to generate a Spring Boot application and then import it into IntelliJ IDE. In the application, it is mandatory to create a /health endpoint if you are using a application load balancer ALB. Otherwise, the /health endpoint is not required. The target group interacts with the /health endpoint to monitor the application's health. If this /health endpoint is not configured, then it will not AWS ECS service will not interact it with the application load balancer. Hence, this ECR deployment will be failed, and the remaining code as per the project's requirement. After that, I will add some dummy endpoint. So here by using Spring Initializer website. I am generating welcome map. After that, I am importing into IntelliJ IDEA. So after that, I am interacting in this video. I am interacting with load balancer. So I am adding one test controller endpoint slash health. I am returning just health string. I am returning. After that, I will create a Docker file and I will add some instructions to build a Docker file. So next point. This is the post point. These are the important points. So here add a Docker file under the application directory. Application directory nothing but Spring Boot application. We are creating it by using Spring Initializer. We are creating one application or multiple applications. That directory. B. Add a Docker file under the application directory is post one. B. If Spring Boot profiles profiles such as such as test test QA comma or prod are used if in your Spring Boot application, if Spring Boot profiles Spring Boot profiles such as test comma QA comma or prod are used create a separate create a separate folder under the project directory under the project directory. Like if we are created environment, suppose profiles we are added, then each profile we need to create a one Docker file. Post we need to create a under project directory. We need to create a one folder. Suppose example, this is the application directory. Under application directory, you can create folder like a you can create like suppose Docker. You can create folder like Docker. In that Docker, you can create other separate folders. For example, I will show here. You can create multiple profiles are there. Docker. Inside Docker, you can create suppose test. Inside test, you can create Docker file. If another profile like QA, you can create another file, Docker file. If another profile prod, you can create another Docker file, right? Every environment have separate Docker file. So third point, the inside the inside the this directory add a Docker file for each environment for each environment. Fourth point, D, include appropriate instructions in the Docker file to build a Docker image for the Springboard Springboard application for the Springboard application. See here. So in this video, I am using one environment only. So I am not using any test QA prod, just default only, like application or properties only. So I am creating only single Docker file under the application directory. So this level I am creating here itself Docker file. So if you are using multiple profiles, then create one root folder directory, then add subdirectory test QA prod, add different Docker files. So second step, add a Docker file under the application directory. This I am doing. So I am deploying single application. If you are deploying multiple applications, you can repeat same process. You can use like this. So if Springboard profiles such as test QA or prod are used, create a separate folder under the project directory. We need to create separate folder for like Docker. Then we need to add environments. Other again we need to create separate folders for each environment. In that we need to create Docker files. Inside the this directory, add a Docker file for each environment. Include appropriate instructions in the Docker file to build a Docker image for the Springboard application. Step 3. Execute the Maven clean install goal. Execute the Maven. Execute the Maven. You can like MVN clean install goals. Clean install goals. This is the step 3. Step 4. So execute the Maven MVN clean install goals. So see here. So first step is done. So we have developed some Spring Boot code. We are added Docker file. In the Docker file, some instructions we are added. After that, we need to do Maven clean install. We need to run Maven clean install. We need to execute Maven clean install goal. Then jar file generated under target folder. So fourth point, once the Maven install goal is successfully executed, it will generate a target folder under the project directory. Inside the target folder, a jar file will be available. Here, this is important. So execute the Maven clean install goals. Once clean install, nothing but it will delete the target folder. Install means it will generate it will run like compare, build, test, install multiple goals. Install goal is nothing but it's not a single goal. In top of multiple goals will be executed. So once the Maven install goal is successfully executed, it will generate a target folder under the project directory. Inside the target folder, a jar file will be available. A jar file will be available. So I will show open the IntelliJ IDEA while using the Docker and Kubernetes, Docker, GitHub Actions. So recommended to use IntelliJ IDEA only. Remember. So this is the fourth point, right? Fifth point, step. Next point, step fifth. So here, this is already exit, but I will develop new project. So this is the welcome app. See, Docker file is there, right? Suppose if using the profiles, like go to SRC Java resources, this is application or properties. The multiple file like application hyphen suppose test dot properties or OML or AML. Like this, multiple profiles are there. Then we need to create a new one folder. Is Docker. You can create like a one Docker file. In that again folder add suppose test. Test inside test you can create file Docker file. This way too you can add if multiple profiles are there. So in this video I'm not using any profile, so I'm created only one Docker file. So read only one Docker file I'm only created. Only single Docker file I'm created. After that I'm deleting the delete. Here in Docker file what is available? Base image available, work directory available. Base image nothing but we are setting the base image Java. So we can also set multiple base images, like mostly Java will be set or operating system will be set. Work directory is nothing but in container we are creating one folder slash app folder. Our files will be stored here. This is the copy. Under target folder, one jar file will be generated, right? After running Maven clean install, those that file we are copying to container location. After that, we are exposing this Spring Boot application port. By defaultly Spring Boot application running on 8080, right? We can also add same. This is default also. If we remove also no issues. After that, we are running Java application by using jar file name file name dot jar. By using this, we are running the jar file. So up to understand, right? See, this is target folder is there, right? So if I run Maven clean go, what will happen if I will run Maven clean go? So here to open any file. So if you are not getting this Maven option, just file, close project, again reopen, it will be appear. So this is the project form.xml. So it is gone, right? File, close project, reopen. It will be open the Maven. It is available, right? So wait some time, analyzing. Here, close this project. This Maven option here not showing. Maybe something went wrong. This too. Close this. Open another one. This is the welcome app CA. I want to show now what will happen if I will Maven clean, and what will happen if I will run this install goal. What will happen if I will execute clean goal? What will happen if I will execute install goal? Here cycle see clean. Observe this is the do one thing post install. Install will generate the target folder, product folder. It will execute some instructions. It will run like multiple goals. So if you are running clean, after that validate. If you are running in clean, validate, it will run the install. If you are using, if you are ambient install, executing this and so once it is done, it will generate the target folder. By using clean, I will in the target folder. So I want to show like one the Maven install goal is successfully executed. It will generate a target folder under the project directory. Inside the target folder, a jar file will be available. This I want to show, and I want to show ambient clean. If I will run this code, it will clean the target folder. So this is the test all done. Target folder here. Still it is running where it will generate jar file as well. See, these are the jar files. This is the jar file. We need to use dot jar. Ignore about this original. Ignore this. After that, clean. What will do clean? Clean will clean the target folder. It will delete the target folder. Observe target folder will be deleted. See, there is no target folder. In IntelliJ, we need to refresh. Right click, refresh every time. But it will be auto gone. Right. So fifth point. Fifth point about to work with Docker commands. You must start Docker desktop. To work with Docker commands, you must start with Docker desktop. Sixth point. I'm closing this exit. So we need to start Docker desktop in your system. Docker desktop must be available, and that should be up and running before executing any Docker commands. Otherwise, we will get Docker daemon errors, daemon related errors. Remember, sixth point. Go to the application directory of the Spring Boot application and open cmd in that location. See, go to the application directory of the Spring Boot application. Go to the application directory of the Spring Boot application and open cmd in that location. So my project is there in desktop. Like my project is there in downloads right now. It is not recommended to add any projects in downloads. You can create one work folder, workspace, and you can add. Suppose assume like it is my project. So it is one project, Spring Boot project. So open the cmd After that, the Docker is up and running. So I am closing. Seventh point, step 7. Step 7, connect to AWS using the connect to AWS using the access key, comma, secret key, comma, and region. Step 8, connect to AWS using the access key, secret key, and region. So for that, go to AWS. Here, post step is done. We have generated jar file. After that, we have started Docker desktop. See now, fourth, when interact with AWS by using access key, secret key, and region. So I am creating now these access key, secret key, and region. So here, username, security credentials. See, observe it is a global. So IAM service is a global for all regions. Access key, create access key, check tick mark. I'm using root user, that's why it is asking. Continue to create a access key. I understand creating a root access key is not a best practice, but I still want to create one. Created, so it will copy access key and secret key. So, but here in this video, I'm just explaining the theory point, so I am not copying there. If you want to delete actions, delete it. Deactivate. After that, this is the copy, delete. So this is done, right? We are connect to AWS using access key, secret, and region. For that command, we need to use one command, AWS configure. AWS configure. Let's I will start CMD. So CMD AWS configure. If any spelling wrong, it will be gives error. See some spelling wrong. AWS configure. Here AWS configure enter. So it will ask the access key. After that, it will ask the secret key and region and response format. We need to enter all the C access key, secret key, region. After that, output format. Then it will be automatically connected. After that, it will be connected. Configure. So it is done. So we assume we are successfully connected to AWS services. We are successfully interacting. Here in diagram, interact with AWS by using access key, comma, secret key, and region. By using these access key, secret key, we are successfully interacting. Fifth step, log into ECR, push Docker image. So we need to log into ECR and push Docker image. I will show 8 point in 8 point. Then then create create an AWS ECR repository in AWS ECR observe 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 the available docker commands, then comma create an AWS repository in AWS ECR Elastic Container Registry. Observe the available docker commands comma copy each command copy each command run and run them. After that, these commands these commands include include build comma tag comma build comma tag comma and push commands push commands. Once successfully executed, the Docker image will be stored in AWS ECR. See, this is the most important. Then create an AWS ECR repository in AWS ECR. ECR stands for Elastic Container Registry. Observe the available Docker commands, copy each command and then and run them right. So these commands include build comma tag comma and push commands. Once successfully executed, the Docker image will be stored in AWS ECR. So I will show 9 point. Let's create the go to Elastic Container Registry ECR. Elastic Container Registry. It is nothing but ECR. So click on create. Check the region, which region you want to create. So it is pointing to AP Northeast -1. So name, see repository name. Suppose I am giving my repository. Give the meaningful. Otherwise, I am giving dashboard. Dashboard. Dashboard repository. Image tag mutable. See, image tags can be overridden. Immutable tags will be overridden. Image tags are prevented from being overloaded. So these tags are not overloaded. So I'm not changing create. So we are created, right? We are successfully created AWS ECR repository. See, this is a URA. This is nothing but image URA. See, so uh, in AWS ECR, every image have one image URA. This image URA we are linking with task definition. Under task definition while creating container we are providing image URA. So whatever image URA available in AWS ECR, this we are linking with task definition under AWS ECR, right? So it is created. If three microservices are there, then we need to create three repositories. Remember, see, click on this is a repository name, that click on repository name. So see, you push commands. You push commands. In previous video, we are successfully Docker started, right? So we are also connected with AWS. So we need to log in into AWS ECR. See, we are using CLI. AWS CLI both are same, but if you want to work this AWS CLI, if you are expecting to work in your system, then you need to install. After installing AWS CLI, we can access through CMD. We need to install AWS CLI. After then we can access through CMD. I am added also in prerequisites. In prerequisites, you need one AWS account. Must Java must be installed. Maven must be installed. Docker Desktop must be installed. AWS CLI must be installed. IntelliJ IDEA must be installed. Postman must be installed. So I am added these prerequisites in that the AWS CLI must be installed. After successfully installed AWS CLI, we can access through CMD. Right? So let's go to commands. This is AWS CLI we are using right now. C commands. This is the AWS ECS login. Where by using this command, we are logging into AWS ECS. By using access key, secret key, we are interacted, we are connected with AWS. Now we are logging into ACR. After logging, we are -t. This is the image name. Dot means current location. In current location, Docker file will be available. See, observe, we are in employee CI. See, this is the employee CI directory. In that one Docker file, see, Docker file will be available. So, must be Docker file will be available. This is a dot. Dot means current directory. Docker build -t image name. This is the dot means current directory. After that, we are adding the tag docker-t. We are building the image. After we are adding the tag. So next we are pushing into AWS ECR. Right? This is the done. So images will be available. This is repository, right? If images will be available, like if we are pushing multiple times, like images like latest will be there, multiple latest will be there. If every push, if you are changing tag, new tag, then it will be multiple tags, multiple images will be there. So I am deleting this one, deleted. This is it done. After that, 9 point, go to the AWS IAM service and create a role such as ECS role, comma, and add the following two policies while working ECR. We need to add two policies. Go to the AWS IAM service and create a rule. You need to create a role such as ECS role and add the following two policies. We need to add two policies. So first policy is policy 1, Amazon ECS task execution role policy. This policy we need to add. Other one B, Amazon easy to container service for easy to roll. This is the optional, but better to add. I will deploy my Spring Boot application into AWS forget. For that, EC2 role is optional, but better to forget. If any internal communications, something internal going on, then it will be failed. So I am adding both. You can also add Amazon EC2 container service for EC2 role. So step 10, go to post. I will create a role. ECS role, Control C, go to EC2, go to IAM services, the IAM, Identity Access Management, create one role. So here, these are the roles, right? Create role, AWS service. If you want to select Elastic Container Service, next, here, one policy is there, container service. Next, to add the name, suppose easy to roll, easy as roll, create role created you. This is the role created, add permission, attach policy. So here search, copy this one. This is the added role is added. This policy not added. Search this policy. Yes. Select add policy. See added. Go to roles. So we are easy. This is the role. Click on role. See, these are the policies. Two policies are there, right? These two policies added. Go to roles. Right click. Delete. Enter the name. ECS role. Delete it. So this is done. 10th point. Create task definition. Create task definition. So we need to create a task definition. So while creating task definition, we need to enter few details like while creating the task definition, enter details like enter details like here post one, click new task definition. We need to click on new task definition. After that, comma second task definition. Task definition family. It will be one title kind of task definition family. So here we need to enter task definition name. Suppose example product product task definition, product task definition, comma, after that third one task role will be there, it will be none. Don't select none also. It will be hyphen symbol. Don't change. Otherwise, it will be fail. Task definition will be fail. Don't change. After that, task execution. Task execution role. In task execution role, this is role were created, right? This ECS role were created. Choose that one. Task execution role. Here we need to choose ECS role were created, right? ECS role were created at step 9 we are created, right? In step 9 after that under container add container name, give the meaningful name, container name, like assume like a give the meaningful name. Example, suppose we are deploying product hyphen otherwise product container under container add container name, right? Example, this one comma, we need to add image image URI, we need to add next one image URI. It is nothing but AWS ECR URI there, right? That one. So next F under port mapping add container port and port name, we need to add port name. Finally create task definition. These steps are involved while creating the task definition. Enter details like click on new task definition family, enter task definition name. Example, this one task role hyphen don't change this. Task execution role, choose ECS role were created at step 9. After that, under container add container name. Example, product container image URL. While creating AWS ECR, we will get the image URL. After that, under port mapping add container port and port name. So this port, suppose our Spring Boot application running on 8080, this we need to map container port, suppose either 8080 or 80801, like that we need to map. Finally we need to create. So step 11 I will show in AWS as well. This is Elastic Container Service. So Elastic Container Service, this is the task definition. Click on create new task definition. So here this is the scroll down. Yeah, post task definition. This is the task definition family. We need to enter task definition name. This is the task definition name. After that, task role hyphen don't change. Task execution role we are created, right? We are created. ECS role we are deleted, but it will be available. You can select. After that, container name, give the meaningful name. After that, image URI, give the this is available at Elastic Container Registry. Copy and paste here. After that, container container port. So you can give, like I mentioned, like 8081 or 8080. You can give our Spring Boot application running on 8080. We are port mapping to container port. Like you can give 8080. Protocol don't change. This is port name. You can give any name. Suppose any name. Suppose product we are creating. We are deploying product application. So give product. Don't change this also same. After that, scroll down, create. So create it. See this process. So this is also done. 11, create a create a cluster. Create a cluster. Either use a single cluster for all microservices services, or create a separate separate one for each microservice either create a cluster, either use a single cluster for all microservices, or create a separate one for each microservice. I will show through diagrammatic. So fourth point done, fifth done, image is stored into AWS ECR. This is done. Next here, this is the AWS ECS Elastic Container Service. So task definition done. Where created container, where this AWS ECR image were added, port mapping were mapped, this Spring Boot application port mapped to container port. This is done. So we are creating the cluster is nothing but logical grouping. Inside clusters, task definition services will be there and AWS forget will be there. AWS forget is nothing but serverless computing. It will run the container. See, these are the three Spring Boot applications. Then we need three task definitions. We need three services, right? So this is the done. So assume we are created. I will show what to create. This is the cluster. Just mention the name of the cluster. Enter the, see, dev cluster. It is giving, suppose test cluster, pod cluster. Give the name. After that, AWS forget only. Don't change anything. Create it. So this is the done. Next step 12. Create a target group. Create a target group. This is the important. Create a target group. Enter details like enter details like a here. Enter details like create. Enter details like choose a target type. First we need to choose a target type. Target type. Mention the IP address. ADD RESS. Mention the choose a target type. Next one B. Enter target. Enter target group name. Assume example product even target group. Third step protocol colon port. So HTTP protocol is a HTTP. colon port is container port configured in task definition configured in task definition D. So for example, protocol port. Protocol is a HTTP port is container port configured in task definition like a 8080 like a 8080. Here target group is nothing but in target group we are adding the our container port. Container port is mapped to, see, this is the container port mapped to Spring Boot application port. Suppose container port is 8080 then Spring Boot port is 8080, it is mapped to container port. Container port is mapped container port added to target group. Nothing but like each microservice have a one target group. Remember, each microservice has a one target group. It is important. So we can use single target group, like we can use every target group as a single port, or we can use multiple ports. So I am using each microservice for separate port. Well, container also I am using separate port. After that, here also I am using separate port. This should be must be matched. Container port. This port must be matched. So this is the Spring Boot application port. Container port must be matched. This port target group port must be matched. Right? Port point. L check. It is important. L check. L check. L check path. Suppose class health, comma, this class health endpoint we created at application code. Inside application code we have created class health endpoint, right? See, this is the health endpoint is important. Otherwise, ECS service will not be deployed without /health endpoint. ECS service will not be deployed. Will not be deployed. Health check path/health, comma, this/health endpoint we created an application code. We created an application code. After that, next, click on the next. After that, enter an IPv4 ADDRESS from a VPC subnet. It will give one option. It will also give remove. Click on remove. No need to enter any IP address. Nothing but enter an IPv4 address from a VPC subnet. This is not required. Just enter. It will like enter the remove. Click on this remove. It will remove. After that, create target group. After that, create target create target group. Create target group. Step 13. See, enter a target group. Create a target group. Enter details like choose a target type, IP address. Enter target group name. Example, product -tg. Protocol port. Protocol is HTTP port or Spring Boot application running on HTTP, right? So we will get an API gateway level HTTPS. But here HTTP running on default port 80 HTTPS running on 443 colon port is container port configured in task definition. So HTTP colon this is the container port. Container port we have only as of now one assume we have only one Spring Boot application where container container port is 80881. Spring Boot port is 8080. It is mapped to 8081, right? So next, enter an IPv4 address from a VPC subnet remote. Create a target group. So go to where these target groups are available. Easy to elastic computing. See, this is the load balancer. This is the target group. Click on target group. So create target group. So IP, scroll down, target group name, product -TG, the protocol port HTTP port. So container port is 80, suppose 8081. My application running on 8081. So after that, I'll check this is the important, otherwise ECS service will not work. This health endpoint must be added in our Spring Boot application. Next, so scroll down, see remove this. After that, scroll down, create target group. If multiple microservices are there, each microservice have one target group. After you are deployed into ECS service, check health. This should be one. If you are getting unhealth one, this definitely deployment will be failed. This should be health one. It will not appear right now. After deployment, see load balancer non-associated. So I will show this. So as of now we are created target group done, right? So next point, after target group, create security group. We need to create security group. We need to create security group. Here steps A, create security group. Create security security group. Security group. B, enter security group name. Enter security security group name. Security group name. After that, we need to add. See here, go to diagram. So this ECS part is done. We are moved to here. While creating the load balancer, we are created the target group. See, incoming traffic, application load balancer, listening on port 80. So application load balancer is listening on port 80. If any incoming traffic coming from the browser, either mobile or desktop, on port 80, it will receive application load balancer, it will receive, right? For that, we need to enable 80 port. First, we will access through public IP. We have container, right? This container running on 8080. So I am enabling in security groups, I am enabling ports 80 and 8080 both to see incoming traffic coming from the browser. So first application load balancer listening on port 80. If any traffic is coming to application load balancer, it will route traffic based on application load balancer regional port is nothing but 80 colon target port. We are created a target port 8081 now that port. And if single service, this is applicable, this is sufficient. If multiple services are there, then we need to use URL path pattern like slash, class level path, method level path. Each microservice has a different class level, method level path, right? Those we need to use to interact with the ECR services. Only one service, then it is target group is sufficient. See, while creating the application load balancer, it will give only option to select one target group only. That's why we need to add after that creating application load balancer, we need to add listener rules. Add rules. In that rules, we need to select multiple target groups. Each service has one target group, and we need to route based on the path URL path. So right, see, assume if three services are there, then go to route traffic. See, this is the application load balancer listening on port 8080. Each microservice have container force, target group port plus listener rules. Target group port nothing but it is a container port. While creating the task definition, we are adding the container port plus listener rules. Mostly path is used. Listener rules mostly path is used. I am using class level path, method level path, right? Node, target group, port, nothing but container port, nothing but container port or yeah, container port, see container port mapped to service port or Spring Boot application port, target group port, nothing but container port mapped to service port, right? Let's see, we are in create security group. We need security groups. So post after deploying into AWS ECS, we are accessing through public IP. So then we are added 8080 as a container port to allow incoming traffic to 8080 port. We need one security group. After that, while accessing through DNS, so application load balancer is running on 80 port. Then here we need another security group. It will allow 80. We can also add alt TCP. It will allow every port number, but it is not recommended. So I will use custom TCP. So create security group, enter security group name. After that, third one, incoming traffic, inbound rules. We need to add two rules. We need to add two rules. So custom, TCP semicolon 8080. So anywhere, 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 IPv4, so source 4 dots, 40/0. Same, copy this, same custom TCP port 80 anywhere IPv4 0.0.0.0/0. Next, the create security group. Create security group. Step 14. So go to now. Security groups also available in ECS, Elastic Container Service. See, this is security group. So create new security group. Roll up. Give the name. Suppose product hyphen security group. After that, scroll down, inbound rules, add the custom TCP port number 8080, anywhere IPv4. This one add same custom TCP port number 80 anywhere IPv4. This is the source. This is the IP address. Yeah. So this is it done like this. After that, scroll down, create. I'm canceling. You can create. Next, step 14. Create. It is important. Create a application load balancer. Create a application load balancer. Here, enter details like we need to enter details like a click on create load balancer. Load balancer. Here example product hyphen application load balancer. Create a application load balancer. Mention here application load balancer. Scroll down, click on create load balancer. Example product application load balancer. So comma B, in B choose application load balancer. It supports for here it will available after click on create load balancer. It will available three options: application load balancer, network load balancer, gateway load balancer. But application load balancer will support HTTP, HTTPS protocol. So we need that. So choose application load balancer. Choose application load balancer. So it supports for HTTP slash HTTPS traffic. It supports for HTTP slash HTTPS traffic. After that, so enter the load balancer name. So load balancer name. Give the some name for load balancer. Example. See, click on clear load balancer. It will not ask here any name. So after that, we need to choose application load balancer. It supports for HTTP, HTTPS traffic. So here we need to mention load balancer name. After that, comma D. So schema, it will ask internet facing or internal. While after creating the application load balancer, edit option will not be there. If you want to edit anything, you need to recreate. Remember, after selecting internet facing or internal schema, it cannot be changeable after creation. Then we need to delete the. So this schema once created, it cannot be changeable. We need to delete and we need to recreate internet 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 facing comma after that mapping here we need to select all checkboxes. Select all checkboxes. We need to select checkboxes. We need to select all checkboxes here. After that, F schema, scheme, internet facing or internal will be there. So we are accessing our application through internet over the network, right? So choose internal facing, mapping, select all check boxes. It is nothing but submerge subnet. We need to select the all subnets. After that, security, security group. We have created previous step, right? Security group, select already created, on step 13, name product -sg security group. See, security group select already created on step created on step 13, name is. See, where created security group, enter security group name. So here if you want to add like product -sg, the security group we have created, right? So this is it done. After that, G. So listeners, listeners, and it is important. Routing, listeners and routing. Here port colon 80 and 80 and select already created target group on step 13. Example product -tg target group. Here listeners and routing. Listeners nothing but application load balancer. Application load balancer is listening on port number 80. Protocol is HTTP. HTTP default port is 80. It is listening on 80. So you can also add our choice listening port like 8081, other etc. So listeners and routing. So this is the application load balancer. Listener is nothing but application load balancer. Routing nothing but it will route the our microservice, appropriate microservice by using target group. If single service is there, if multiple services are there, by using target group and path pattern or adders, some like query parameters, by using it will route the request. So here select already created target group on step. So you can ask here multiple questions like why we need to use path pattern. We can attach multiple target groups there, right? So while creating the it will allow only one target group to select. So after that, if you want to attach multiple microservices, then add we need to create listener rules. We need to add rules. So while adding the rules, so we need to pass the target group. Each microservice has one target group. We need to add target group. In next step, we need to add some condition like path parameter. We need to mention. So that option is given. We need to mention both port container port and path pattern. So if single service target group is sufficient, just port is sufficient. If multiple microservices are there, we need to configure the target target group, nothing but container port, and we need to add path parameter. See, listeners is nothing but application load balancer. Load balancer listening on port 8080. It is a default port of HTTP. Routing is nothing but, so it is a target group. Target group. Target group. In target group, our container port we are adding, and L check and point also we are adding, right? Listeners and routing port colon 80 and select already created target group on step 13. Example product TG product target group. After that H create. It is very important, I am repeating. Application load balancer running listeners nothing but listening on port 80. Routing is nothing but it will route the appropriate microservice by using the target group. By using the target group, if multiple microservices are there, then each microservice we need to create one target group, and we need to add rules. So if single service is there microservice, then it will route by using container port. This container port we are added in target group. But if multiple microservices are there, then so while creating the application load balancer, it is giving one option to add one target group only. Then we need to add regional rules. While adding the regional rules, if multiple services are there, we need to add regional rules in that regional rules. So we need to choose the one target group, and we need to add the one condition. Condition is nothing but path pattern, headers, host name, different options are there, query parameters like that. So we need to choose one. So after that, so this is all about application load balancer. I will show how to create. So scroll down. This is load balancers. So this is load balancer. Create load balancer. See, choose application load balancer. It will support HTTP port, HTTPS. These are the protocols. See, suppose this is the browser request coming from the browser. It is going to, it will reach the application load balancer. Application load balancer listening on port 80. So based on the target port and path based condition based, it will route the appropriate microservice, right? So it will support HTTP HTTPS. Create. So mention the load balancer name I am giving. Suppose meaningful product one hyphen application load balancer. See, scheme cannot be changed after the load balancer created. So if you want to change, we need to delete. This is internet facing. So select. After that, scroll down. Networking, we need to choose. In networking, here UPC were not created. Availability zones. These zones we need to select. All zones we need to select. Availability under zones. Subnets will be available. So this is it. Security group were created, right? Those security group, that security group selected. After that, see, listeners and routing. Listener is nothing but application load balancer port. Routing is nothing but target group. Target group. In target group, we are adding our container port. So 80 is a HTTP default port, right? need to select target group. Product will create a target group. So after that, scroll down, create. So we have successfully created application load balancer. Right? After that, here some important points will be there here. Next, step 15. If if it is if it is a single single springboard application we can we can route we can route traffic from the application load balancer to AWS ECS using a single target 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 group. Listener listener rules are optional. Listener rules are optional. Yes, here suppose if if it is a single if it is a single springboard application, comma, we can route traffic from application load balancer to AWS ECS using a single target group. So here listener rules are optional. Here listener rules are optional. See, if it is a spring if it is a single Spring Boot application, we have only one Spring Boot application is there. So we can route traffic from the application load balancer to AWS ECS using a single target group. Listener rules are optional. So these rules are optional. Suppose, see, we are created, these are the load balancers. We are created load balancer. This is load balancer. Scroll down. These are the listeners and rules. So this is the one target group. This is the one target group. Manage roles. Edit roles. See, edit roles. This is the select this one. Edit roles. See here, the target group. Next, save changes. See, it is not giving any option to. It is not giving any option to add listener rules. Then, if it is a single Spring Boot application, we can route traffic from application load balancer to AWS ECS using a single target group. Listener rules are optional, otherwise not required. Not required. Listener rules are not required. Rules are not required. Yeah, these rules are not required. Next, step 16. Step 16. If there are multiple Springboard applications, if there are multiple Springboard applications, we need to we need to multiple target groups, one for each Springboard application. Springboard Spring Boot application and we must add listener 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 rules listener rules listener listener rules are mandatory 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 here. So if there are multiple Spring Boot applications, if there are multiple Spring Boot applications, so we need multiple target groups, one for each Spring Boot application, comma, and we must add regional rules. Regional rules are mandatory. Regional rules are mandatory. Step 17. I will show this step. So suppose each microservice has a one target group, right? I am creating new target group. So it is IP based. Scroll down. So this is the microservice port 28080 I am giving. So else check is mandatory, else deployment will not work. It will not respond. Name, suppose user hyphen target group. Next, remove the IP. This one remove. Next, create target group. So now assume we have a two microservices. We have a two target groups. So load balancers were created recently. This is where created. Scroll down. Select manage rules. Edit add rule. You can add rule. So add rule. See, we have option to rule name. Suppose user hyphen rule. I am giving user hyphen rule. Next, this is the conditions preview. Next, we need to add condition. Suppose path pattern. See, so many are there. Host headers. These are the conditions. Header, path, HTTP request method, source IP, HTTP header, string query. I'm choosing path. You can add like APA slash user slash star confirm. So after that, next, here we need to select forward to target groups. Here we need to select target group. This is the user we created. Next, click next, give the priority. This is the microservice to right, give to. Next, create. So we have successfully added rule, right? It is a listener rule. So see if there are multiple Spring Boot applications, comma, we need multiple target groups, right? We are added one target group, one for each Spring Boot application, and you must add regional rules. Regional rules are mandatory. Regional rules nothing but in regional rules we have one application load balancer. In that we need to run multiple Spring Boot applications. For that, like we are getting the incoming traffic from the browser application load balancer is running at 80. So we want to route traffic from application load balancer to appropriate microservice. So we have one single application load balancer there. So we need to add For each microservice, we need to create each microservice. We need to create single target group. Assume I have a two microservices, then I am created two target groups. So microservice is each microservice running on container like 8081 one container port, 8082 is another container port. In target group, add port like 8081 and one target group for 8081, another target for 8082, right? Target group port and container port must be matched. Our Spring Boot application mapped to target group. This target group port mapped to listener port. Listener is nothing but application load balancer. So 17, I will add steps to add listener rule. Add listener rules. These are the steps to add listener rules. Go to load balancer. Load balancers. Click on ALB. ALB load balancer. Application load balancer. Example, we are given like product one, sub product application load balancer, semicolon. Next up, go to load balancers. Click on application load balancer. Application load balancer example product ILB, right? Next, scroll down, comma, see listeners and roles. Listeners and roles. Select all. See, it will be enable manage. It will be enable manage rules. Then add rule, comma, next D. Next, enter name. We need to enter the rule name. Enter name. After that, click on next. After that, add condition. It is condition nothing but path pattern, host header, HTTP request method like that. Like we need to choose one, like multiple options are there, like host header, comma, path, comma, HTTP request method, comma, source IP, comma, HTTP header, comma, query string, comma. So up to these are the options are there. See, mostly used path. I will also show in this video path. See, choose one like host header. These are the add condition. Multiple options are there. Host header, path, HTTP request method, source IP, HTTP header, query string. These many options are there. After that, F. So here, after that choosing, here manage rules and add rule option will be there. Click on enter name and after entering the condition, so click on add condition. So suppose select path enter enter path like slash API slash user slash star. After that, we need to confirm. After that, we need to enter on the next. After next, we need next choose target group. After that, priority. Suppose priority you can give like 2, 3 like that. Choose target group. After that, next comma priority. So priority give priority number. After that give priority number. Suppose like suppose 3. After that next then create. So step 18. This is step 18. Here step 17. Add listener rules. Go to load balancers. Click on ALB load balancer. Example product ALB. It is created where at the time of where created step number 14. This is created step 14. Step number 14 were created. Scroll down, see listeners and rules. Select all. Manage rules under add rule. Enter name. Next, add condition. Choose one like host, header, path, HTTP request method, source IP, HTTP header, query string. Mostly used real-time path based. Suppose select path. So I am selected path, enter path like confirm next, choose target group. So like every microservice has a one target group, right? So we need to choose target group contain the container port and health slash health endpoint. Slash health endpoint is mandatory. Give priority number like 3. Next, then create. So it is done. 8.18 point. So after, so in 18 point, create a service. We need to create the service. So enter details like enter details like a click on create comma choose task definition b choose task definition name from drop down after that see enter service name enter service name So example product service semicolon then D under under network network section under network section choose security group security group we need to choose security group example product security group it is created step number let's check where it is created 13 step number 13 this is created this security group we need to select at service level and application load balance level we're creating application load balance level we need to select the security group right so you can mention like here enter details like after that fourth step is done fifth one F ABCD E enter load balancer section under load balancer under load balancer section choose ALB so here add other step as well post step click on cluster click on cluster click on cluster name after that scroll down see service option to change to B C E F so here change under task definition it will be on family will be there we need to select task definition here we need to select task definition here definition we need to select task definition this is created at step this is created at let's check task definition 10 step number 10 it is created so under task definition name family we need to select in family task definition name here we need to select task definition name it is created at step 10 after that so after that check revision is pointing to latest if not select latest under task definition name family it is be one title kind of after that family will be there so here from drop down drop down will be there select task definition name this task definition were created here. After that, check revision is pointing to latest. If not, select latest. Here under networking section, choose security group. Security group. So this group, the group is created. Step 13, right? After that, here under load balancing. So select load balancing type. So select load balancer type of select application load balancer application load balancer. After that, after observe container mapping here, observe observe container port mapping. Like suppose our application running on 8080 air map to 8081 like that, it will be available. After that, so H, we need to choose the load balancer we are created, right? We need to here don't create any new application load balancer. So choose application load balancer name created at scroll down. Let's check where created. Create application 14. Step 14 were created, right? Step 14 were created load balancer. That one select. Choose application load balancer name created at step. Right? Next, next step, we need to select here. So choose existing, choose existing listener and target group. Don't create new one, just select existing one. Choose existing listener and target group. At the last, we need to create. So click on create. Click on create. So these are the steps are there in service. It is most important. So this is service. These are the steps. It is most important. Let's see. So post go to the this is the cluster. Click on cluster. See here. Click on cluster name. Scroll down. See service option. Service option. So this is the cluster name. Scroll down. See this is services. Services create. So click on cluster name, scroll down, see services, 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 want to create services, services, click on create. If you want to create, click on see, scroll down, post we need to select task definition. Under task definition family, we need to select see under task definition name family, we need to select from drop down select task definition name. is already created. Check revision is pointing to latest. If not, select latest. So this revision it is not pointing to latest, then if it is pointing suppose this, then change to latest and enter the service name. See, enter service name example. After that, under networking section, choose security group. So we are already created security group. Under network section, choose security group. Existing security group. This one existing security group. Select. So after selecting, scroll down in load balancing. See, under load balance, select load balancer type. So load balancing under this is the load balancer type application load balancer. So observe container mapping application port container port. See, observe container port mapping application port container port. After that, application load balancer create new load balancer. Use existing. Click on use an existing load balancer. Choose existing load balancer. Listener. Choose existing listener. While creating where listener port mapper to 808. This is the listener. Scroll down. Scroll down. Target groups. Select existing target group. So existing target group. Both health must be same. The health URL must be same. Scroll down. Create it. So I'm canceling. This will be done. After that, step 19th. Step 19th. Access application. Access application by using ALB application load balancer DNS domain name system URL. So step 20, if this is a microservices project, if this is a microservice project, repeat all steps for each service available in the project. So as of now, I am explaining like a single service. If multiple services are there, then repeat. If this is a, if this is a microservice project, repeat all steps. If this is a microservice project, repeat all steps for each service available in the project. So I will show where the DNS available. So go to easy to elastic compute load balancers. So click on load balancers. So under load balancers, see select this load balancer. See this is a DNS. See this is a DNS.com is there, right? See I am opening browser. It enter HTTPS colon. This is a DNS. See HTTP. See HTTP is a default port for HTTP Default port is 80. Default port is 80, right? So yeah, in this video we are successfully understand steps to steps to do manual push Docker images to AWS ECR and deploy a Spring Boot application on AWS ECS and how to route traffic from AWS LB application load balancer to AWS ECS forget. So this process is same for monolithic application or microservices. So see, finally, we are accessing by using DNS URL. We are accessing the our welcome app. So now I will start development. So I will create only welcome app. Load balancing. Here it is a application load balancer. Let's understand about application load balancer. Load balancer. This is a step one load balancer. Routes routes are forwards incoming traffic to the appropriate micro services. Services are monolithic application. Monolithic applications. See, load balancer routes incoming traffic to the appropriate microservices. Microservices are monolithic applications. This is step one. Step two, we need to know types of load balancers. Load balancers. Balancers in AWS. So first one, a application load balancer. Application load balancer. So this application load balancer work is used for routing HTTP slash HTTPS traffic with content based routing. Content based routing. Content based routing. Example HTTP colon double slash. So after that some string .com slash API slash user slash star. There are types of load balancers in AWS. Application load balancer used for routing HTTP, HTTP yes traffic with content based routing. So it is a protocol. So content based routing, it is nothing but this is the content. It is a condition or legend or rule, right? Second one, network load balancer. Network load balancer. Network load balancer used for handling TCP slash UDP traffic with high performance and low latency. Third one, gateway load balancer. Gateway load balancer. So this work used for interacting, interacting, interacting with third third party virtual appliances, virtual appliances, appliances, appliances via a transparent transparent gateway, transparent gateway. Step 3. Here, this is step 2 important types of load balancers in AWS. Application load balancer. This application load balancer works on HTTP or HTTPS protocols. So, if multiple microservices are there, then we need to use content-based routing. Content-based routing. These are the conditions or listener rules. Say application load balancer used for routing HTTP slash HTTPS traffic with content-based routing. So assume it is a DNS in application load balancer. DNS URL will be available. Domain name system, by using that we can access our application. This is a path, like class level path, method level path. This is a wildcard symbol. Star means any. Network load balancer used for handling TCP/UDP traffic with high performance and low latency. Gateway load balancer used for interacting with third-party virtual appliances via a transparent gateway. Step 3. So in step 3, here in our now we are using application load balancer. Our Spring Boot application working on HTTP locally. So if it is any domain names are there, it will works with HTTP or gateway API gateway there. API gateway it will work with HTTPS, right? Application load balancer. Application load balancer. Application load balancer is nothing but ALB, application load balancer. See, AWS application load balancer routes incoming traffic to the appropriate ECS forget ECS forget containers. So in these containers we can store like microservices. Each container we can store independent microservice or monolithic application or monolithic application based on target group based on target groups, comma, regional rules. So regional rules nothing but conditions. Regional rules, example of regional rule, path pattern. See step 3, application load balancer. Load balancer is working. AWS application load balancer routes incoming traffic to the appropriate ECS forget service or containers. service, service are containers. So in these containers, our Spring Boot applications are available. Each container have a one Spring Boot application that is either monolithic application or microservices, independent service. Based on the target groups and listener rules, it will route the appropriate. See, AWS AWS application load balancer routes incoming traffic to the appropriate ECS suppose ECS service based on target groups, comma, listener rules. Listener rules nothing but example, path pattern, like class level path, method level path, it will route the request. Okay. The AWS application load balance routes incoming traffic to the appropriate ECS forget service based on target groups, comma, regional rules. Step Step 4. See diagram also. Incoming traffic from browser. Incoming traffic is coming. So application load balancer is listening on port 8080. So based on the target group and path pattern routes traffic based on application balancer listening port target for like based route traffic based on target port and your path example /ab /welcome star. This is one path. So if three services are there, then how to route traffic? See, our application load balancer listening port and 80. So if any request is coming based on the target group, in target group, port will be there and health endpoint will be enabled. That endpoint, health endpoint also were manually created based on the target group, port, and regional rules. Regional rules nothing but class level path. This path it will route to appropriate microservice like welcome app. This is the one microservice. Another microservice. One microservice is running on 8081, another is running on 8082, another one running on 8083. These are the container boards. These are the Spring Boot application boards, right? So it is understand. Fourth, routing rules, conditions. Routing, routing. This is not routing. You can change to listener rules. Regional rules. Regional rules are nothing but conditions only. Conditions. Regional rules are nothing but conditions. Here, host one using application load balancer and target group like one application load balancer and one target group. By using we can communicate with single service agent. This is a monolithic application by using load balancer and single target group. We can route traffic to single monolithic application without any regional rules like path pattern, headers, query parameter, without any, we can route the traffic. So a application load balancer routes traffic to an ECS service task configured as a target group. Configured as a target group. Nothing but application load balancer routes traffic to the ECS service task configured as a target group. Like in target group, we are configuring one port number. So that is container port number. That container port number we are mapping at, we are adding at ECS service, right? In ECS service, we are mapping at task definition. The task definition managed by service, right? So, for example, for a for a single application, for a single application, comma, create one target target group target group. So if a monolithic application, then one target group is sufficient. So for a single application, create one target group, right? Next one, be listener, suppose target groups and listener roles, listener roles, nothing but conditions, listener roles, here target groups and listener roles. Like I have a three microservices are assume they are the three microservices running on different ports. These are the different container ports, right? So for that three microservices, we need to create three target groups. This target group port and container port must be same, and listener rules nothing but conditions like class level path, method level path, adders, uh, parameters. We need to, these are the conditions, right? So here point is here ALB route traffic based on ALB routes traffic based on target groups using host names comma URL paths comma and listener. These are the listener rules only. The application load balancer routes traffic based on target group users using their conditions, using the listener rules like host names, URL paths, etc., etc. Previously, we are explained, right? Listener rules. These are the listener rules. Target groups and listener rules. Listener rules are nothing but conditions. Application load balancer route traffic based on target groups using listeners rules and target groups uses listener rules like host name, URL path, etc. Application load balancer routes you can otherwise change into control X and first we need to select conditions, right? Application load balancer routes traffic based on listener rules. Listener rules. Example. Suppose example path path pattern and target groups. That's it. Target group. Here, listener rules, nothing but conditions and target groups. Application load balancer route traffic based on listener rules and listener rule path pattern, host headers. etc. Like if you want to add post headers, headers etc. Based on this, it will route to appropriate microservice, right? Next, third point, here, here only, each micro, each microservice should have, its own target, target group configured, configured with, configured with listener rules. Otherwise, change. Each microservice should have regional rules, should have one target group configured with regional rules is fine. Next, step 5. Step 5 is routing rules conditions. How many are there? We need to know that. Listener rules, nothing but conditions, right? Conditions. We need to know how many are there. So, post 1, post header, post, post header, comma, second one, B, path, comma, third one, HTTP, request, request method, comma, fourth, source IP, comma, fifth, HTTP, headers, next one, E, F, query string, query string. These are the listener rules or conditions. Post header, path, path pattern. You can also mention it. Path pattern like class level, path plus method level, method level, method level path. Request HTTP request method, source IP, HTTP address, query string, right? This is the fifth step. 6 here. This is important. Default ports for HTTP and HTTPS, default ports for HTTP and HTTPS. HTTP port, default port is 80. HTTP default port is 80. HTTPS default port is 443. So listener rules also called conditions by using host headers, path patterns, HTTP request method, source IP, HTTP headers, query string. So default ports for HTTP and HTTPS. So HTTP port 80, HTTPS port 443. See here, above example. This is I am said like this is a DNS application load balancer URL, right? Here I am not mentioning any port. So in I am selecting HTTP and I am providing 80 port. So HTTP default port is a 80. If we are using protocol as a HTTP and port as a 80, then it is optional to add. If we are using protocol as the HTTPS and if we are mentioning port 440, then optional to add like this is URL, right? .com : 80 or 443. These are the optional, right? Next, step 7. So in step 7, port mapping. Port port mapping. We need to understand port mapping. See, Springboard Springboard default Tomcat port is Springboard. If we are adding, suppose in Springboard I am added Springware dependency. Springware dependency. Then default port is then default port is 8080, right? So this Springboard port default 8080 port I'm mapping to container. So step 8 mapping container ports. Mapping container ports. Container ports. Here. So map the container port to the Springboard application port. Map the container port to the Springboard application port. Example, if we are creating Docker images manually, then if we are running Docker images manually, then we can use this command. Like we need to use this command like docker run -d detached mode -b port mapping 8081. See, suppose this is a welcome app, it is running on 8081. This is a Springboard port is a 8080, container port is a 8081. So container port :808. This is a Springboard port. So we need username. This is the username. Suppose here resume like a AWS ECR username. After that, image name. This is the welcome app, right? Image name tag always latest one. Step. This is the step 9. In step 9, routing traffic based on target groups. Here, how routing will work. Routing traffic based on target groups. Based on target groups. Here, routing traffic based on target groups. For that, I will draw a diagram. Paint. So suppose this is a load balancer. I have 3 microservices are there. So this is microservice 1. This is microservice 2. This is the microservice 3. So here container port : Springboard port. Decrease the size to. Okay. See here 8080 is the application port, Springboard port 8081. This is the container port. Here also 8082. It is a container port 8080. It is a Springboard port. Here also 8083. It is a container port 8080. It is a Springboard port. So here this is the welcome hyphen app, welcome app. So this is the email name must be small letters. Welcome app 1. This is the welcome hyphen app 2. Remember, email names must be small. Welcome hyphen app 3. So see, I have a three Spring Boot applications are there. So these are there in containers. So we are pushed to AWS ECR. Suppose this is a AWS ECR, AWS ECR. This AWS ECR we are mapped to, we are linked with task definition. This task definition managed by service. This service running on AWS Fargate. This Fargate is available on AWS ECS, right? Suppose do one thing, demo this. These are the three microservices. So this is the Spring Boot application port. This is container port. So this is a application load balancer. So incoming traffic is coming. Incoming traffic. Incoming traffic. So suppose one request is coming through browser. So after that, it will route the appropriate microservice. It will route the appropriate microservice. So it will route the appropriate microservice. These are the three microservices. Each microservice have one target group. Suppose host 1 target group port is a 8081, comma, we need to add path pattern. Suppose slash API slash, this is a welcome 1 star. So based on target group port and path pattern, it will route to this service. Here also same, based on target group port and path pattern. Sometimes all services target groups will be same. Then it will route based on path. Here also, see, this is the three based on the target group and path. It will route to appropriate microservice. Appropriate microservice. It is nothing but here. This is the target group and listener role. We are configured here path. Listener rule as a path. See, incoming request coming from the browser. Application load balancer listening on port 80 based on the target group port and listener rule path were added. It will route traffic to appropriate microservice, right? It will route traffic to appropriate microservice. So I'm closing. Next year, ninth point. In ninth, application load balancer listener. Application load balancer listening on port 8080. Application load balancer here. Application load balancer listener on a specific port and forwards forwards traffic to the appropriate ECS. Forget only running right containers. Forget container. This container may be microservice, single microservice, or monolithic application. Microservices microservices are mono monolithic 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 applications based on target groups. Here application load balancer listener on a specific port, so it is running on some specific port 80 and forward traffic to the appropriate ECS forget container. This container is application like independent microservice will be there are monolithic application will be based on the target groups. Nothing but application load balancer listener on a pod routing traffic based on target group. See application load balancer listening on port 80 and based on the target group and path pattern, it will route the traffic to appropriate microservices. That change application load balancer, load balancer, listening on port 80 and based on target group and path pattern. Its routes are forwards traffic to AL traffic from ALB to appropriate is as service, right? This is the first point. Suppose if you want the example, load balancer port 80 and 8080 is a container port plus this is a load balancer port, this is a target group port plus path pattern. We need suppose path, we need to mention path. Next, node if there are multiple microservices, then create different target groups. Each service have one target group. Each service have one target group. Note, if there are multiple microservices, then create different target groups. Each service have one microservice. With each service have one target group. Suppose if two microservices, then create two. So after that, here are note if there are multiple microservices, then create different create different target groups or use use a single target group. If you use a single target group and add multiple rules. In rules also, we need to add target group, so it will not work. Okay. Step 10. Note if there are multiple microservices, then create different target groups. Target groups. Target group. Each service have one target group. Each service have one target group. Target group. And add listener rules. Listener rules, right? After that, we need to know ways to access a Spring Boot application on AWS. Ways to access a Spring Boot. Ways to access a Spring Boot application on AWS. We need to know how many ways we can access Spring Boot application on AWS. Ways to access a Spring Boot application on AWS. So by using public IP, we can access by using public IP. Example, access the Spring Boot application via a public IP. We can access by using public IP. Example, HTTP colon / some IP 80 colon 117 colon 141 colon something slash, after that class level path, method level path, suppose user something. By using public IP, we can access. I will access through public IP. After that, I will access through DNS, domain name system. Second one, DNS name. DNS name abbreviation is domain name system. Here also we can configure custom domains. So custom domains are works on HTTPS, right? So our application load balancer supports HTTPS. So we can able to use custom domains and we can able to configure through Route 53. Access access application using ALB, comma ALBR N application network load balancer DNS name. So application load balancer and network load balancer have DNS available. Access application using application load balancer or network load balancer. Network load balancer DNS names. So example here, this is the example of the DNS .com up to .com, some URL HTTP. Example up to this. Third one, CL custom domain. These custom domains Custom domain. This custom domain we can configure at API gateway level, load balancer level as well. So configure a custom domain. Configure a custom domain with route 53. In route 53 we can register our domain. We can by using AWS gateway ACM certification we can validate. We can hosted zones. Configure a custom domain with route 53. Other DNS services for easy to or ALB. Easy to or ALB. Next one, fourth one, this is the AWS API gateway. Gateway also it will give endpoint, some HTTP URL. Exposes, we need to create here. Expose, we need to create REST APIs. REST API, APIs through AWS API gateway. AWS API gateway. So here example HTTPS colon double slash www.server test.somestring.com. So step 11, here ways to access a Spring Boot application on AWS. This is most important, you should know. Public IP we can access, or DNS name we can access, or custom domain we can access, or AWS API gateway will provide HTTPS URL. API gateway, yes, expose REST API through AWS API gateway. Nothing but it will not, we are not creating any APIs here. Just we are mapping application load balancer are there. We can also map that one. Just we are routing traffic to application. This is the API gateway. We are routing traffic to API gateway. At API gateway level, we can validate request parameters, path variables, request body. After that, we can add versioning, late remitting. Suppose this is the versioning. This is the test version. We can restrict how many requests will come. This kind of AWS API gateway. Next, here 11 AWS application load balancer DNS here application load balancer DNS domain name system. It is a domain name system allows clients to access your load balancer via a domain name instead of a public IP. So AWS application load balancer DNS. See, application load balancer DNS domain name system allows clients to access your load balancer via domain name instead of instead of public IP. So this like application load balancer will provide domain name. Also, Elastic Beanstalk also, if you will deploy our Spring Boot application on Tomcat server, then it will also provide some domain name. Next, next step, 12. So, routing traffic to 3 microservices using a single AWS routing traffic to routing traffic to 3 microservices using a single AWS application load balancer. So here we are discussing it in diagram on paint routing traffic to 3 microservices using a single AWS application load balancer. Configure the application load balancer with different target groups for each microservice. Configure the application load balancer with different target groups for each microservice, one target group, and listening on a different port. So, listening on a different port, like configure the application load balancer with different target groups for each microservice, one for each microservice. The each target group configured with unique or same port sub configured with unique port like 8080, 8081, 8082. Suppose 8081, 8082, 8083. We configure the application load balancer with different target groups for one configure the application load balancer with different target groups for each microservice each microservice have one target group. Each microservice have one target group. Each target group configured with unique port. Each target group configured with unique port. Step 13. Next, step 13, route. Here you can add another point. Routing decisions are based on based on path based, or host based rules configured at the ALB level. See, so we need like target groups. If multiple microservices are there, suppose three microservices are there, routing decision are based on path-based. Path-based, it will verify the path and path before we are giving target group as a single target group. We are mentioning routing decisions are based on path-based or host-based rules configured at the application load balancer level. So next, ECS cluster configuration. ECS cluster configuration. See in diagram, this is the cluster, right? Single cluster, logical grouping, right? So when we need to choose single, when we need to choose multiple, I will explain. Single ECS cluster, single is ECS cluster, best for cost efficient efficiency, best for cost efficiency, shared resources, comma, and simpler management, simpler management. So B, separate ECS cluster, separate ECS cluster like independent services. Each microservice. Suppose each microservice have one cluster. When we need to go this better for strict isolation, strict strict isolation, better for strict isolation, scaling or security, security needs, security needs. So ECS cluster configuration, single ECS cluster, better for cost efficiency, shared resources, and simpler management. Separate ECS cluster, each microservice. A single ECS cluster for best for cost efficiency, shared resources, and simpler management. Separate ECS cluster for each microservice. This is for the R microservices. So each microservice better for strict isolation, scaling, and security. Now we are successfully understand what is load balancing, route incoming traffic to the appropriate microservice or monolithic application. It will route the incoming traffic to appropriate microservices. Types we are understand after the load balancer, application load balancer, listener rules, default ports, mapping, container ports, routing traffic, ways to access, DNS, cluster. So now I will create a here. I will create, so I will create welcome app and I will explain. I will show practically, I will show. Let's start coding. Manually push Docker images to AWS ECR. ECR stands for Elastic Container registry and deploy a Spring Boot application on AWS ECS. So after this successfully done, I will access through public IP, Elastic AWS Elastic Container in that in service on public IP there. I will try to access. So it is working fine. Then I can how to route traffic from application load balancer, AWS application load balancer to AWS ECS forget. I will show same process for the monolithic application or microservices. So it is a like a it is a single service. So if you do for multiple times, like suppose three microservices, you can do same process three times. Then it is like a microservice project. So post verify the prerequisites. You need one AWS account. I have Java must be installed. Let's check Java is installed or Java hyphen version. Java is installed. After that, Maven must be installed. MVN version. MVN version Maven installed. After that, Docker desktop is there. AWS CLI must be installed. Let's check AWS version. By using, we can check AWS CLI. AWS CLI also installed AWS CLI we can access through this command prompt. After that, IntelliJ IDEA must be installed, Postman must be installed. Those two are also there. So I'm closing. See, access key and secret keys must be generated. Create security group and add inbound role. Add IAM role. Role name ECS role. Two policies are there. So some note, when using an application load balancer and target group, it is mandatory to manually create a health endpoint. So in this video, we are using application load balancer. It is listening port and 80. So we need to one health endpoint as well. So let's see here by using Spring Initializer, let's create one application. I will create now product app. So Spring Initializer, I will add two endpoints, one health, three endpoints I will add. Java Maven 3 dot Spring Boot version, latest is 3.4.0. Okay, I will choose this. Group ID, tag must be same. FST, artifact is a project name. Product hyphen app. So here also product hyphen app. Group name, package name must be same. Jar, Java version 21. After that, add dependencies. Spring verb and Lombok. These are two sufficient. So generate the project. Go to downloads. Check it is downloaded. So it is yes, it is downloaded. Close this one. Right click, extract here. Extraction done. Minimize. Open. IntelliJ IDEA. Open. So in downloads, product tab. Okay. Trust project. In this post tab, here in this post tab, we need to write some Spring Boot code and we need to create a Docker file. So it is scanning Maven projects. Wait some time. It will be done. We need to do in post step two activities. We need to expose one health endpoint is mandatory. It will require for target group to it will check by using health, unhealthy, it will give those statuses. If unhealthy, service deployment will be failed. So slash health endpoint must be required. While using application load balancer, slash health endpoint is mandatory. So it is creating, wait some time until resolving dependencies of project app. Meanwhile, login into AWS. AWS. Recently, like within 20 minutes before only I am logging, so it is without asking passport, it is automatically login. Just now I login, so it is without asking any username, password login. See, it is by defaultly this region selected. I want to deploy, decided to, I'm decided to deploy my application on US East 2. So I am changing the region. So check the region. If you are created any services in some region, suppose you are created easy to install, but after one day you are open, but that easy to install is not available. That means does not mean that is deleted. Maybe this region will be changed. Check the region. So let's see. Downloading meanwhile, open notepad. This is the done. Add model, model one, service one, add pack, other one, package, controller. So let's add model class, new class, product. So private integer ID, private string name, private product have ID name. So price you can take double price. Always use wrapper text. Remember, always use wrapper text. Setter in service. I will output three objects. Getter. After that, toString. No are constructor. All are constructor. So this is done. Service. Right click new. Java class. This is the product, right? Product service IMPL. Other item service. So create one method. Public. It should return list of product. Control Shift O for imports. If it is not working, then wait. Uh, product. Go to model. Refactor. Rename. Change to capital P. Class name must be capital. So import. This is also import. So get products for three products. I will add code here. Return. So list dot of is a Java 9 feature. By using we can add multiple objects. We are using all our constructor, right? Use the product of three, right? Suppose ID, name, suppose apple, and price. Suppose some price dot zero. This is the one. Control C. Another one. This is the other one. This is the other one. So three objects, semicolon, right? Take another one. Suppose public string message. Like I will take this as a post call string. I will return welcome to FST. This is some dummy data. Don't take like this is like a not string. So string. This is the service is done. Add controller. Right click class. So add controller product controller annotate with at rest controller auto service private. This is the product service IMPL product service IMPL semicolon auto. So this is done. Public response entity of list of product get all products. These products were hard coded, so no body, no parameters. This is list of product is nothing but body, but no parameters. So return new response entity of this is product service IMPL dot get all products, comma HTTP status dot either use OK or created. I will use this time OK. So this is done. Method level path at get mapping slash support all. You can use class level path request mapping slash product. So one method we are added. Copy same method. So let's change to post call. Let's check I am able to access both or not. Get mapping or post mapping. I can able to access a string. It will be message return service dot message. This is the done. Add health controller. It is important. Health controller. Go to health controller. Annotate at rest controller. Do one thing. Paste previously you copied, right? So change to health. This is return type is string. Method name also I mentioning health. Return healthly. Healthly Three spelling right. Three endpoints are done right. So run Spring Boot application. Right click. Run as. Enable the fallback. Meanwhile type http://localhost default port 8080/health. So it is still building. So it is still building. Wait some time. Yes, this is done. Building done. So hit enter. Health endpoint. Health endpoint. It is not reachable. Let's check. Slash health. Hit. Now it is okay. Response healthily. It is working fine. Same change to product slash r hit. Yes, we are getting change to post product slash message right hit. Yeah, three endpoints are working fine. So three endpoints are working fine. So go to application dot properties, add server dot port, server dot port is equal to 8080. Check the spelling server dot port. After that, close this, add Docker file, new file, D capital, Docker file, enter, enter, base image with open JDK 21 from OpenJDK colon 21 hyphen JDK hyphen SLIM. So check the spelling from OpenJDK colon 21 hyphen JDK hyphen SLIM. If spellings are wrong, then these are the commands are wrong. These are the keywords. These are the values. So set the application directory. Set the application directory. What dir class app. Next one. Copy the application jar. Application jar. For that, copy jar file is available in target, right? Target slash star. Star is a wide call symbol, a name. After that, copy to product hyphen app dot jar. So export application port. Export application port. Export application port. Export 8080. Then execution. Execute the application. Execute the application. For that command, entry point, entry point, Java space, Java space, hyphen jar, common space only. This is the product app.jar, product app.jar. See once spelling. So check the spellings. This is the base image. Base image I am setting to Java. Mostly we will set like Java, Windows, OS related. This is the work directory, nothing but in container I am creating slash app folder. So after that I am copying this target under target for jar file is available, right? This I am copying to container. I am exposing application port. This product app is running on 8080, right? I am also tested through 8080 report. This is nothing but Java hyphen space, Java space, hyphen space, jar file name. It is a Java command to run the our Spring Boot application through jar file. This is the command. So here go to, so we are successfully generated product tab. After that we are successfully imported into IntelliJ IDEA IDE. After that some piece of Spring Boot code we are developed. Docker file also done. Next up Azure Maven goals clean install, right? So if you want to add final name, but that is no use. So I am skipping that part. Optional only. That is not mandatory. Next, clean. Clean. Once clean done, then run the install goal. Install. Once install goal is done, see observe it will be generate one target folder. Whatever in target folder, one jar file is available, right? That jar file we are copying to container. So under target folder, one jar file will be available. That jar file we are copying to container, right? So meanwhile, create access key, and so after that jar file is generated, I will need to start the Docker desktop. After that, next, say we need AWS CLI, right? So generate one access key and secret key. See region I am selecting ES used US is 2. For that access key and secret key, click on username, security credentials. So access keys, create one checkbox. I am root user, so it is asking. I understand creating it. Root access key is not best priority, but still I want to create one. So this is because of this is a root account. That's why it is asking. Access key, access key, secret key, secret key, region, US hyphen, East hyphen 2. Let's check again. So this is a IAM is a global service. That's why it's global. So go to Elastic Container Service. Let's check US hyphen East hyphen 2. US hyphen East hyphen 2. After that, see this is the clean install successfully. These two goals successfully done. So one target is generated. See under target, this is the jar file. So I am using star.jar. Any file name will be picked up, right? So this is the done. So here, go to First one done, second one done. Jar file generated. We need to start the Docker desktop. Start the Docker desktop. Without Docker desktop, Docker commands will not work. You will get daemon errors. Remember, if you are getting daemon error, then so you can realize that Docker desktop is not up and running. If Docker desktop not up and running, then only you will get daemon errors. So it is starting. Meanwhile, go to our product tab. So we are in product tab. Let's wait. Starting the Docker engine. See now up and running. Right. Open the CMD. Here AWS configure. Check the spelling. If spelling is wrong, it will some lines of text will come in here. So copy access key. Control C. CMD. You must be there under the product tab, your application, and under this Docker file must be available. Otherwise, Docker commands will not work. Control C, Control V, US hyphen, East hyphen to check the spellings, otherwise it will not work. JSON successfully connected. So here, third step, fourth is done, fifth, then need to create ECR. So mention name like product hyphen repository. So remaining are defaults only. I'm not changing. Create. This is the done. This is the URL, image URL. Take this one. Mention like email URL. We need to add at task definition. So go to it will give some push commands. See right now no images. Remember this. We are using AWS CLI, right? So through CLI command prompt we are accessing AWS CLI. Suppose go to window. This is for the so this is for PowerShell. So go to use the AWS CLI. Here AWS tools for PowerShell. This is for the PowerShell. This is for the CLI. Huawei. This is nothing but we are logging into AWS ECR by using access key, secret key. We are connected to AWS, so we are logging to ECR. AWS ECR, Elastic Container Service. Once successfully we are logging into ECR, then we are building a product repository image, right? See, login success. We are building a Docker image. Build -d product repository. First, it will set up or download the JDK. After that, it will build the jar file. This is the done. Three commands are done. Two are done. Three. This is the tagging. This is a this is a username. This is the tag This is the username. This is the image. Image name. This is the tag. So paste, enter. This is the done. Next, last command, push. Paste, enter. So we are pushing to AWS ECR. See, meanwhile, do go to this one. Check post one done. Account is there. Java done. Maven. Docker desktop. CLI intelligent. Postman. Where created. Create access and secret keys must be generated. Create security groups and inbound rules custom 8080 comma 8080. Create two security groups. Create one security group. Add two inbound rules. It should allow income traffic 80 and 8080. So EC2, go to EC2, then security groups. So security groups. The one default security group is there. This region, same region, check region also. Sometimes it is moving to other regions. Create security group, group name, scroll up, group name, product, hyphen, security group. You can add last, like if you're creating security group, repository, like that. Easy to understand. Inbound roles, custom TCP, 80 port, anywhere, IPv4, 0.0.0.0/0. Add another one, port is 8080, anywhere, IPv4. So create security group. These are expecting the description as well. So I add this, same, create. So security group is done. Let's check if there any add IAM rule, ECR rule. So add, this is also, go to IAM. Then prerequisites will be completed. This is the last one, roles. Create. So use case, elastic, container service, nest, see it is one policy is added, nest, enter the name, ECS role. These are the roles we are creating. So description I am not adding. Create, the role. See it is loading. Meanwhile, go to this one. We are added two policies. So this is for ECS and EC2. I am also adding EC2, Amazon EC2 container service for ECS, Amazon EC2 container. So I add this as well. See one is there, right? Search Amazon EC2, Amazon EC2 container service. Container, enter. Control X, not here. It will searching for the available policy names. Click here, add policy. So search AWS easy to container. Here container service for easy to container service for this one. Third one, add so added go to roles if you want to verify easy as role just now were created. It should policies to be two. Easy to policy is optional, but I am added. So, like by using, we can forget, we can connect to ECS Elastic Container Service, and we can also connect by using EC2 as well. So these two policies, like this is done. So all prerequisites are done. So let's check in Elastic Container this image is created or not. Under repositories, see this is the repository. Click, see image is created, right? So this is also done. Go to Elastic Container Service rule we are created, right? Elastic Container Service. Elastic Container Service. So create one task definition. Create new task definition. Task definition le product hyphen task definition. Product hyphen task definition. It is a AWS forget. This is the don't select any task role. A task execution role. We are added one. So we are added, right? It is not showing. Let's go to another tab. Do open another tab. New tab. Roles. So these are the added. But here not showing. The easiest task execution role provider. This is also same two added. Same policies. Easy to role. Execution role policy. Let's check why it is not giving. Easy to container service role. Container service for easy to role. Execution role policy. Here two policies are there. Let's check. Execution role and execution role policy provider. Do one thing. Select this one. Otherwise, just refresh it. Easy to task execution row. Which policies are there? Let's check. So these policies are there. Otherwise, select same. Easy to task execution role. It is not showing, so easy to task execution role. Select this one. Same policies will be there. These two policies will be there. After that, scroll down. Container is a product hyphen container image URL. Select this one, image URL. Copy. If you want to add tag, add latest. This is the optional if you want to add, else ignore. Container port 8080 application. This is the product some name. We are mapping. Application is running and here we are exposing 8080. So application is running on 8080 port. We are mapped to 8080 container port. So this is done. After that, no more changes. Create. This is done. Go to cluster. Create cluster. Cluster name. Product. See, it is giving suggestion like dev cluster, QA cluster, prod cluster. But I am single application, so I am giving application name. Product cluster. Cluster is nothing but it will grow task definitions and services. No more changes. Just create. So cluster product cluster is in progress. So once it is successfully created, wait sometime it will be successfully create. Once this is done, then we can create the service. Instead of adding these roles manually, we can also select, we can also create at the time of creation of service. This is done. So go inside cluster, scroll down. This is the service, create, select the task definition. Revision is the latest always. So this is the product hyphen service. Yeah, networking. Select our created security group. We are created, right? Product SG. This is where created. After that, I will access through public IP. After that, I will add a load balancer. So I am not touching this one. Create. If it is working fine, then I will create. First, I will create load balancer, target group, load balancer. Then I can create a again service. I can create product service deployment is in progress. It takes a few minutes. So wait some time. If you want to, yeah, refresh it. you will get updates here, progress, running. Post will be, it will come like a red color. After that, it will change into this color. After then, it will change into green color. You can also click on this service name. You will get deployments here. Deployments. These are the deployments. Go to service. It will take exactly 2-3 minutes. If it is taking more than that, then it will be something went wrong. It will be, no doubt, it will be fail. So tasks are running. So wait some time. Service. You can also check in cloud formation. What are the events it is triggering? These application logs will be stored in AWS CloudWatch. In AWS CloudWatch, we can like application logs, container logs are available. This CloudWatch logs automatically enabled only. I am not enabled. Maybe defaultly it auto selected. So by creating task definition or service, in this we will get logs as well. Go to see observe product service cluster. Close one. Go to this refresh. One deployment completed. See, service deployment is completed, green color. So click, let's see how many deployments are there. It is deployment current status one. Like it is post deployment, it is failed, then it will trigger another 3 times. It will be triggered. So go to service, tasks, click on this task, copy the public IP will be there. This is public IP. Go to Postman. Instead of localhost, use this Control V, send. The post call is working. Change to get product all. So it is also working. Then check health. Health, send. It is also working. So go to cluster. If you want to add load balancer, then we need to delete. It is not editable. So delete this one. Yeah, post go to easy to target groups available right here. Target groups available. These are the target groups. Click on target group. Create IP address. Scroll down, target group name. Product hyphen target group. This is the container name. Our Spring Boot application, our container running. Our container running on 8080. It is a product app container protocol HTTP. So no more changes. This is important. Else check class else. It is very important. Otherwise, we are deleted red service. After creating service, it will not work. Remove this. After creation of service, after this load balancer is created, we will create right service. Then it will not work. Moreover, it will show one unhealthy that time if we are not configured health. See port 8080, it is a one target is running and this target group is have port 8080. Okay. So go to load balancers, create one. Three types are there: application load balancer, network load balancer, gateway load balancer. Select application load balancer. It will support HTTP, HTTPS. Create, then load balancer name, product IP, application load balancer, internet facing. See, schema cannot be changed after the load balancer is created. So networking load balance, see, network mappings. Select three availability zones. Select these three. Scroll down security groups. We have created one security group. Product NG. Select this one. See, these are the important listeners and routing. HTTP default port is 80, right? So I am not changing. We need to select target group. This is if single service is there, it will be work fine. Like if multiple microservices we are deployed in Elastic Container Service, then we need to add routing rules. I will show that is also once this application is working. Then create load balancer. Once this is done, go to Elastic Container Service. So go to cluster, create the service, give the name. This is service, right? Select the task definition, service name, product, product hyphen, service, add, product hyphen, app hyphen service, decided task one. So networking, select the security group, this one. Next, close this networking, load balancing, select application load balancer. See container, this is a Spring Boot application port. This is the container port. Both are 8080, but ALB is running on 80 only. Application load balancer, choose existing load balancer we created right just now. This one. Next, listeners here created 80. This is the while creating the load balance like application load balancer listener also we are selected this listener is attached with this target group. This target group is our Spring Boot application container running and container port is 8080. Target group we have created one this product same. See this check else path this path and we are created easy to both path must be same, right? Next create. So once successfully created, we can go to application load balancer and we can copy DNS name. By using that DNS name, we can access our Spring Boot application. After that, I will show how to, if multiple microservices are there, then how to route the traffic from application load balancer to appropriate EC2 services. By using load balancer, we can route traffic different services like Lambdas, ECS, GraphQL, etc. So in this video, I am showing for easy to. Next video, I will try to use AWS, Lambda. After that, GraphQL as well. Post will be coming like the green color. Refresh it, it will change to other color. After that, finally, it will change to green color. You will get at last completed. So once successfully completed, let's check how many deployments happen. After that, health. Health also I will show. It should be healthly one. Product app service. See one deployment completed. Let's go to service. This is the service. It will take around 2 to 3 minutes. So meanwhile, let's copy the go to elastic container, go to load balancers. So we have created on load balancer. Always verify this. Sometimes it will be changed. Region will be changed. This is the DNS name, domain name system. It is a DNS name. Copy this one. This is the application load balancer name. So go to Postman. Instead of this, change it. See why I am not adding port, because while listener I am choosing 80. 80 is nothing but 80 is a HTTP. It is HTTP is running on 80 protocol. HTTP it is running on 80 protocol. Then it is optional to add HTTPS. It is running on 443 protocol by default. So if you are using gateway endpoint, then it is running on 443. It is optional to add 443. So now I am chosen port like 80. It is a HTTP port. It is optional to add. Yeah, suppose yeah 80. It is optional to add. Optional to add. Suppose if we are added at application load balancer level 8080 listener port, then it is mandatory to add, because 8080 is not a default port of HTTP, right? So let's check it is created or not. Yeah, completed. Post to verify the how many deployments, single deployment. Let's check health. See one healthly. Go to load balancer also. Health is important. Check. So click this target group. Here also must be health up. The health 1 L3. If 1 and L3 is there, then this is also not the right. Then you can try delete and you can update the health endpoint. Must be 1 L3, right? Closing. Just go to Postman, get call, post call the class product class all. It is a get call product all. It will three objects will be there, right? It is working fine, right? So if you want to share anyone, copy this, share with anyone. Next message is a post call. Let's see, get is working. Change to post. This is a post call. Application load balancer will support post call. Yes, sir. After that, health health endpoint. change to get call. Yes, it is working right. So it is a single microservice. If multiple services are deployed and easy to then create another target group, IP address, target group. Suppose user service. This is user service. User target group. It is running at 8081. Suppose container port is 8081. Then health is important. Otherwise, it will not work. Service will be failed. Health. Remember spelling also. Double check. Next, scroll down. Remove. Create target group. Go to application load balancer. So click this application load balancer. Scroll down. Listeners and roles. Select all. Manage roles. Add role. So rule name. Suppose you can mention user hyphen rule. Next, add condition. Add condition. So suppose these are the post header, path, HTTP request method, source IP, HTTP header, request query. Select path. Suppose this microservice path like slash API slash user star. Suppose this API is class level path. After that, user is also class level path star. Any method level path like save all, get some save all, some names method level names. I am using star means all methods. So confirm. Here we need to next choose the target group. Forward to target group, redirect to URL, redirect fixed response. Forward to target groups. We have a user target group. See, we have a user target group. After that, next, it is a second microservice. So priority give to two path patterns here. If any, so based on the target group and this path pattern, route the request to appropriate microservice here. Listener rules, there are the two target groups are there. Product, TG, user, TG. Target group, this product, target group is running on 8080, it is running on 8081. Next, create. By using listener rules, we can route the traffic to appropriate microservice. So in this video, we are successfully understand manually push Docker images to AWS ECR and deploy a Spring Boot application on AWS ECS. After that, how to route traffic from AWS ALB to AWS ECS forget. So, how to route traffic from application load balancer to AWS ECS. Right? Thank you for watching. For more videos, please subscribe to this YouTube channel.